All right, we're going to start with 8.5 partial fractions. So we're going to decomposition of n of x divided by d of x. So number one, we divide if the degree of the numerator is greater than or equal to the degree of the denominator. Okay. Usually step one is not done. Okay. This is like a rare occasion. I don't know how to spell occasion. I don't know. Looks a little better. I don't know if it's right. Okay. So like usually it doesn't happen, right? I should have said that better. Usually does not happen. All right. We usually start with 2, which is the factor, the denominator. Okay. 3, write d of x as a summation of fractions with each factor of d of x as a separate denominator. 4, write each number with a degree 1 less than the denominator. 5, reconcile created summations with the original function. Okay, we'll go through all these. Note that partial fractions is a college algebra topic, typically not covered in college algebra for lack of time. Okay, so if you haven't seen partial fractions, I think you'll be okay. If you've seen it, better for you, right? You'll understand this breakdown a little bit better. But it's not dire need if you haven't seen it, okay? All right. So example 1, use partial fractions to integrate. So we have the integration of 1 over 4x squared minus 1 dx. Okay, so of course, like I said, number 1 is usually not used. Okay, so 2, let me make this a little bigger. 2 says to factor the denominator. Okay, well, if I factor the denominator, that's a difference of squares. I hope we remember those rules. This gives us 2x minus 1 times 2x plus 1 dx. Okay, so it starts off by making this factor, okay? So then it says, write the denominator as a summation of fractions with each factor of the denominator. So I'm going to rewrite this. So each factor, so 2x minus 1, and yes, I know I have it blank right now, summation plus, and then 2x plus 1. Okay, dx. Okay, I'm just showing how to separate the factor for the denominator, okay? Let me change colors here. So since I don't know the numerator, this is A and this is B. Okay, we're gonna now do algebra to figure this out, okay? So I'll do all the algebra in red. Okay, so basically we have A over 2x minus 1 plus B over 2x plus 1. Okay, so I want to rewrite this addition as one denominator. Yes, I know, we just separated it. It's okay. So the LCD is going to be 2x minus 1 times 2x plus 1. So 2x plus 1 and then 2x minus 1. Okay. Let me go back to red. So then this is going to give me 2ax plus a plus 2bx minus b over 2x minus 1 times 2x plus 1. Okay. So what I do know here, let me erase the slide. So what I do know here is that I don't have a common term in the numerator. I mean, yeah. But I do know that this whole thing is equal to 1 over 4x squared minus 1. Okay? I do know that because that's what's inside. Okay? So these are equal, correct? So the denominators are equal, but now my numerator is not equal. So what I'm going to do is I'm going to separate my constant terms and my variables. Okay, so who are my constant terms? Well, a minus b equals, and what's my constant term on the left-hand side, which is just 1. Okay, let me move up my variable. Okay, so now I want all my variables. So on my numerator, I have 2ax plus 2bx. And then that equals 0. Because I don't technically, I'm going to put 0x. Because I technically don't have any x values. Okay, so I'm going to rewrite this a little bit differently. I'm going to GCF what they have in common. I know they have a 2 in common as well. But I'm only going to take out the x just for right now. So it gives me x times 2a plus 2b. And then here I have 0 times x. So these x values, right, I don't really need that because I'm just showing that that's the term that has the variable. So in reality, I know that this inside, that needs to be the coefficient of x, right? So then I have 2a plus 2b equals 0. Now I'll take out that 2 and get rid of that 2. So if I do 2a plus b equals 0, divide both sides by 2, then I get a plus b equals 0. Okay, so now I have this constant and that variable one. So what do you see that we've done before? I can work with those two equations to solve for a variable. And I hope you've seen the addition method. A minus b equals 1. If I add these together, I get 2a equals, those go, equals 1. So I get a equals half. And if I know that a equals half, b also equals half, because they need to add up, oh no, sorry, this would be negative. They have to add up to 0 or subtract to be equal 1. Okay, so now I have my a value and my b value. So we go back. Red and black. We go back and I know now what to write in my a. So my a was half. So 1/2 over 2x minus 1 plus negative 1/2 over 2x plus 1 dx. And then I continue. I'm actually going to separate each of these into its own integral. So I'm going to take out that half and give it the integral of 1 over 2x minus 1. So I was about to write plus. Minus 1 minus 1/2. Oops, I forgot my dx. The integral of 1 over 2x plus 1 dx. Okay, now I'm going to do the substitution method. So u is going to equal 2x minus 1. So du is going to equal 2, sorry, not 2x. 2 du. I don't have a 2, so this is going to become 1/2 du equals dx. I made another mistake. Okay, so then I have this integration would be 1/4 of ln of u, which is 2x minus 1. On this side, I have basically the same substitution, but I'm going to use v just so that it's different, but same concept, right? And then dv is going to equal to 2 dx. And again, 1/2 dv is equal to dx. So minus 1/4. And the natural log of the absolute value of 2x plus 1. And then, of course, plus c. But here I have the rule that we know from logs, right? So it would be a quotient rule. So this would really be 1/4 natural log of the absolute value of 2x minus 1 over 2x plus 1 plus c. Outside of that, you can't really simplify. Okay? So that's the first example. So again, we need to factor the denominator. So hopefully you're saying they have x squared in common. So x squared times x plus 1 over 4x squared plus 2x minus 1 dx, sorry. Okay. Okay, so I'm going to rewrite it separating my denominator. Now, when I have anything that is like squared or cubed or to the 4th power, whatever, however many exponents and wants to have, I need to duplicate the pieces, meaning that from x squared, I can get an x value or I can get x squared. So if I had cubed, then I would do x squared, x cubed. Okay? So you take all the exponents basically into consideration. And then plus x plus 1. Okay, so this time I have a. I remember it's always one less exponent. I don't think I said that on the first example. So if I have here x, then it's going to be b. Here, it's going to be a. Here, because I'm considering the x, I don't consider the x squared, so it doesn't have to be bx. It just b again, because I already took it into consideration for the first one. Okay? And then here, one less exponent means c dx. Okay? So I'm going to separate this one a little bit differently. Okay? So let's separate... this time I have x squared as a value. I have x, and then I have a constant term. So constant term is always a number, correct? Okay, so let's start with... Oh, wait. I'm not there yet. Sorry. I had to multiply by the LCD. So this would be x times x plus 1. This would be x plus 1, and then this one would be x squared. Okay, before I separate that, let me do this. So let me go back to black. So then this is going to be 8x squared plus 8x plus bx plus b plus cx squared over x squared times x plus 1 dx. Okay, now I can separate it. Okay, so which values do I have that equal x squared? So let me do the red. So this one has x squared and this one has x squared. So I'm actually going to write it without the x squared. I just have a plus c. And then which value up here has x squared in the numerator? So without the x squared, I just have a 4. Okay? Then I'm going to do the same thing for the x's. Which values have x? So I'm just going to write it without. So a plus b equals 2. Oops. And then our constant term, we only have b. So b equals -1. Well, that made life a little bit easy because we have that b equals -1. Can I trickle it down? Well, can I put -1 here? And then, so I have, this would give me a equals 3. And then can I put a here, which is 3 minus 4? So c equals 1. So now I have values for a, b, and c. So I can rewrite this and go back to this one before the red. So I have the integral of 3 over x plus -1 over x squared plus 1 over x plus 1 dx. Okay, so if I take individually, these are all summing, right? So here I would have, well, I'm going to rewrite this one because that one's going to be different than the other two. So I have the integral of 3 over x minus x to the -2, that's what I mean, plus 1 over x plus 1 dx. So this is going to give me 3. Oops, so why did I put the integral? Let me take off the integral. That's integrated already. 3 natural log of the absolute value of x minus, this is going to give me x to the -1 over -1 plus the natural log of the absolute value of x plus 1 plus c. Okay, let's clean this up. This will give me 3 natural log of the absolute value of x plus, I'm just going to write it as 1 over x plus natural log of x plus 1, quantity, absolute value here, plus c. Okay, now what I have here, kind of like the quotient rule, but this time it's addition, so it's a product rule. So, but first I'm going to take care of this 3. What has happened to the 3? Well, it becomes the exponent. So I'm going to have the natural log of the absolute value of x cubed times, the addition rule says to multiply, x plus 1 absolute value plus 1 over x plus c. And I would leave the absolute value because we don't know the value for x, and then x plus 1 inside, so we need to make sure that's okay. Okay. So the next one we have, it's already factored for us, so we don't have to do that much work, but it has an exponent. So remember, if it has an exponent, I have to first write it as itself. So x squared plus 9, I guess I can take off the parentheses. And then plus x squared plus 9 quantity squared. Okay. Okay, so remember that I said it's always one less exponent, right? So inside we have x squared plus 9. So one less exponent would mean that I have x. So we would write ax plus b. Okay, and remember you can ignore the square, but I need its own values. And normally we go alphabetically, so ab, what would come next? Cx plus d. I hope you're saying that. Okay, so now the only thing I have to do is this one is going to be the only one that needs the LCD, because the other one has the LCD already. Okay, so yes, here you're going to multiply those two out. Okay, so if I do the box, or whatever you do is fine with me. 8x b. So this would be 8x cubed, 9 8x, bx squared, and then 9b. Okay, so let's do the algebra. So this is going to give me the integral of ax cubed plus bx squared plus 9ax plus 9b plus cx plus d over x squared plus 9 quantity squared dx. Okay, so let's do the algebra. So this time I have an x cubed value, an x squared value, an x value, oops, and then the constant term, so that's a number. Okay, so for x cubed, I really just have a, and that equals, here's my original, I don't have an x cubed, so that equals 0, it's not there. X squared, I have again just b, so then b equals 1, because the coefficient is 1. For x, I have 9a plus c equals -1. And then for the constant term, I have 9b plus d equals 9. Well, they already did 2 of them for us. And they gave me the value of a. So then in reality, this just equals to c equals -1. Here, we plug in 1 for b. So 9 times 1 is 9 minus 9. So then this becomes d equals 0. Okay, so now I can go back to this integral and actually integrate. So I have, okay, so denominator x squared plus 9. Okay, so x squared plus 9, and then on top I have ax plus b. So a is 0, so 0x plus 1 is 1. Plus, and then I have cx plus d. Cx is -x plus 0. So then I have -x over x squared plus 9 quantity squared dx. Okay, so now here in this integral, let me write it again over here. And then I'll put minus x over x squared plus 9 quantity squared dx. Okay, so now here, if I do u substitution for the first term, it's not going to go anywhere. But I can do u substitution for the second term. Okay, so if you notice this one, let me change the color. It's actually a special integral. So I'm actually going to rewrite it as the integral of 1 over x squared plus 9 dx minus the integral of x over x squared plus 9 quantity squared dx. Okay, so that one stays there. It's actually one of our arctangent rules for our paper that we have. So that one's perfectly fine, the first term. Second term, let's do u substitution. So then I have u equals x squared plus 9. So then I have du equals 2x dx. All right. I'm not going to use that 2, so 1/2 du is equal to, not 2, x dx. Okay, so the first one, I'm gonna take the integral for arctangent. So this becomes 1/3, following the formula, 1/3 arctangent of x over 3. Okay, minus, so this is going to become 1/2 the integral of u to the -2 du. Okay, so I kind of did a few steps. I hope we're okay with that. Okay, but it's 1 over u squared. Okay, so then let's take the integral for that. So I get 1/3 arctangent x over 3 minus 1/2 times u to the -1 over -1. And I put the plus c. So then this is going to give us 1/3 arctangent x over 3 plus 1 over 2 times u, but u is x squared plus 9. And that's it, plus c. Okay, so if you see something that you can't, there's no substitution for it, there might be a special rule for it. Okay, and that ends the section.